Let's see what you got.
Welcome to another video. This video is going to be pretty quick. I'm going to talk about how to solve some very basic inverse trig functions. The reason why is just to get your brains ready for how to solve these things and to understand that while an inverse undoes a function will also undo an inverse. So here's the idea. Very basic, very straightforward, just getting us ready to solve some of these equations coming up in just a little while. If ever you want to solve an equation, isolate the variable. In order to isolate the variable, sometimes we can factor to do that and create these factors. But with functions like this, we want to isolate the thing that contains the variable. So if you have an inverse trig function somewhere in your equation, you need to isolate it. So what we're going to do is say, if we can isolate the inverse trig function, then we'll take the appropriate function and do it. So for sine inverse, we'll use sine. For cosine inverse, we'll use cosine. For tangent inverse, we'll use tangent on both sides. There's not a whole lot of domain work to deal with because this x can actually fit in whatever domain you need it to. So we don't have to deal with a lot of that. It's going to work out just fine for us. You're going to see that as
in the
we go
way
through.
that you go.
So let's get started. If we have 4 sine inverse of x equals pi, the first thing we want to do is, of course, isolate sine inverse of x so that we can undo it with the sine
So this glass is everything in
there.
there.
By 4.
Remember all 2-1 on z function, because Penrose's just going to line across here, make a big topology problem on 3b, 1b.
The only way that we can get x by itself is to use sine on both sides of this equation.
Is in binary already to bend either's. That's what it is. I mean, it's like when I'm hitting you from the Ouija board. It's Ouija. Yeah. We usually get through because it helps with the numbers.
So sine of sine inverse of x, that's just going to be x.
Math can be...
On the right-hand side, wait a minute, sine of pi over 4.
Math can be... Well, what's a good
That's something we can actually do. So
like
sine
I said,
of pi over
because
4
it
is
does
square root
this
2 over 2.
inevitably.
Use your circle if you remembered it already, that's great.
But little quadrant and lens, because I'm using that sine, cosine,
and we're done. We just solved that. In fact, if you plug that in,
this is
this
simplification.
Would actually work.
Remember, this is the fastest, easiest way to do it. I can always go fast, but I can't always go comprehensive. What we got? How's all basic?
So,
inverse.
Isolate the inverse function, then take the appropriate function on both sides. Same thing's going to happen here. 3 times tan inverse of x equals pi. Let's divide both sides by 3.
One of the best I've seen. Like I said, you got to get those short clips and start taking stuff down with headstones. Like, give out the name, put out the process, figure out which ones are the photon, Bell's equality, field theory, sine,
is that appropriate
the
inverse. Let's take tangent on both sides.
Cosine, usually, but it can also be the black body radiation in any form. So you can start with any form. Apples have field theories, tree have field theory.
On the right hand side, tangent of pi over 3. Well, tangent of pi over 3 is going to take square root of 3 over 2 divided by 1/2.
Where I want to lay people over time on systems of their cost over the index to the trajectory. That number at a place gives you a specific...
So we should know that tan of pi over 3 takes the y coordinate over the x coordinate. Square root of 3 over 2 divided by 1/2 is square root of 3. Let's move on. So 3 cosine inverse of 2x equals 2 pi. It looks a little bit more difficult, but remember the idea.
2 pi. Whenever you see that little circle, you see a little circle. 2 pi is a little circle.
So we're simply going to divide by 3 here.
One of these little circles. Which 3 on the board am I looking at right now? I'm against war, famine, and pestilence, right? Or death's looking down the pipes at me. I am conquest against something else on the index.
Once we've done that,
I got Larry. We worked this mission. This next time I stretched it, I lost Larry, but kept everything else in containment. They have a different trajectory. Yeah, it's not biased across the board, but it helps me determine the field topology that I need inside of there by what are real valid numbers. They have a number valid times, loads the saw 15 minutes. And you start to graph that in there. Sine x minus x. Or minus sine, really, is the number.
2 pi over 3.
And then you could multiply it, give it to something. So graphing's not real hard, like I said.
So it's in quadrant 2, x is negative, cosine
gets there. Break that down,
dividing both sides by 2. Now
what I know is there are parts on the internet, and there's a way to do whole deep field, right? And so what I do is usually when I'm breaking down an operation, I would say here's the beginning, the middle, and the end, which keeps you clocking in, which is a much larger first square. it's 0. They're equal. They're
terms that have
congruent, x
cosine
and y.
inverse
The
of
geometry
x
here,
and
singlet states,
just like
rotations,
every other
pi,
time that you
the
have
triangulation of
terms
ramping
on
up is
different
what I
sides
said
of
in
your
the
equation,
Hadron
you can bring them
Collider.
on one side and combine
The
them.
Hadron
And you
Collider
can
one,
actually combine this. If
you
this is
got to
4
ramp it up.
cosine inverse of
You
x
start from
and 2
actually
cosine inverse of x,
negative
let's
1,
subtract
1,
2
into
cosine
1,
inverse of x
1,
from both sides
1, 1.
and add 2 pi. This
And
looks
so,
familiar.
and
Getting
actually,
all of our
the
extras
WIMP,
on one side and
the
everything else on the other
orientation
side.
of
This
this
is
thing
isolating
being
that
the
variable.
WIMP, or the, what I used is, what did I use? I gotta check to make sure. So you get that circle-y thing back out now. So I just write the standard model in it and give it
So
weights.
we've subtracted 2
Takes some time. 7 minutes is not a long time.
Added 2 pi to
Remember,
both sides. These are actually combinable.
this
So
page
if
probably
we have
took me
4
8
of
to 10
something
hours to
minus 2
draw.
of something,
A lot of
altogether
thinking
you
to
have 2
put it
cosine
there.
inverse of x.
But when you get it there, you start to, let me make sure I got this right. Yes, I started up on the anti-tau. And I said what that does is start to begin the CT paradox. It is moving forward from top key position 0,
2 pi
which
divided by
was
2 is just
originally
pi.
1. And so they act in bits and bytes. Now what we're putting inside of there, again back to certain quadrants,
Lastly, now that we've
or how the
isolated that
topology of
inverse
that
function,
gravity
we use
figure 4
cosine. The
works.
appropriate function is going to be root
The
cosine
graduated
inverse
cylinder
on
being
both sides of
gravity
our equation.
has a bunch of spin, has, again, from the top topology of the beaker there, looking down it at the ball hitting the bottom.
Because cosine of cosine inverse simplified, that's literally one of our identities there.
They
for
are
inverse functions, we're
that
gonna get
close, and that's
x.
generally why I like this model, because it
On
actually,
the
when you
right-hand
break
side,
this down,
cosine of
it's the
pi
neutrino.
is -1.
Now, the
So
neutrino
cosine of
across the
180
board
degrees or
says
pi,
couldn't
that's
zero
gonna
back,
be
I have to
negative
find
1.0,
gravity
x
waves
coordinates -1. We know that's
to
-1.
do the machinery to do
And we're
that,
done.
and those machines
So I hope
will
that
make
makes
numbers.
sense. It's honestly really quick.
Yes.
Isolate your inverse function and take the appropriate, honestly, pairing function, that root function.
They'll figure it out.